Okay, so we're done with Chapter P and kind of moving into Chapter 1. Chapter 1, I hope the sections aren't as long as they were in Chapter P. It's a really important chapter. It's that the whole chapter, the concept is factoring. And in section 1.1, we introduce the concept of the greatest common factor. So the whole chapter, for the most part, involves factoring polynomials. And as we go through the chapter, maybe I'll better define this, but factoring a polynomial is essentially rewriting a polynomial as the product of polynomials, so that the factored version of what you write would multiply back to the original polynomial. That's probably not a stellar definition, and not a definition we need to know, but I'll explain more of what factoring is in each individual section. In section 1.1, the section is titled The Greatest Common Factor, and then the instructions for most of the problems say factor out the GCF. GCF is just shorthand for greatest common factor. The instructions factor out the GCF implies that you know what the greatest common factor is and you know how to factor. So the question would be, what is a GCF, or a greatest common factor? Generally, it's a monomial. I'll say, better say usually. And I'll even add to it that we usually write to the left of a parentheses. And it can consist of just numbers, just letters, or a combination of numbers and letters. It could be just a number. It could be just a letter, or maybe several letters if the problem has several letters, or it could be a combination of a number and a letter. And again, there might be more than one letter. For most of our problems, we're living in the world where we only have one letter. So this is what it can be, and then how do I determine what it actually is? I should probably put this on another page. I'll say the GCF of a polynomial, or just the GCF, contains the largest number that divides evenly into the coefficient of each term in the problem. And then I should do a for example. For example, in this problem, 8x squared plus 10x plus 12, the largest number that divides evenly into 8, 10, and 12 is 2, because 2 goes into 8, 2 goes into 10, 2 goes into 12. 4 goes into 8, but 4 doesn't go into 10. 4 does go into 12. 2 is the biggest number that goes into each. So the number part of the greatest common factor would be 2 in that particular example. Here's another example. If I gave you, 20y to the 4th minus 16y squared plus 8, I believe 2 goes into 20, 2 goes into 8, and 2 goes into 16. I would say 2 is a common factor, but it's not the greatest common factor. And in this section, we're trying to find the greatest common factor. There's a number bigger than 2 that divides evenly into 20, 16, and 8. And I'm ignoring the letters at this point. When I'm trying to find the non-letter part of a greatest common factor, I just look at the coefficients and the number that doesn't have a variable. And in this particular problem, the GCF would be 4, because 4 goes into 20, 4 goes into 16, 4 goes into 8. And it's the biggest number. There isn't a bigger number that divides evenly into 20, 16, and 8. Yeah, another example, stellarly spelled. Another example. If I gave you 3x squared minus 5x minus 7, here, the only numbers that divide into 3 are 1 and 3. The only number that divides into 5 is 1 and 5. The only numbers divide into 7 is 1 and 7. So the biggest number that divides into 3, 5, and 7 simultaneously is 1. And when the greatest common factor is 1, sometimes I say it doesn't even have a greatest common factor. I might even say, in this case, maybe there's no GCF. 1 is kind of a trivial GCF that we might not consider. So the greatest common factor can consist of just a number, just a letter, or a combination of a number and a letter. To figure out if a number is part of a greatest common factor, when you look at a polynomial, you look at all the numbers that make up the polynomial, and the polynomial could have 2 terms, could have 10 terms. The biggest number that divides into each of the numbers that I see is the greatest common factor, and I almost think that this calculator does the greatest common factor. Maybe GCD. I'm going to try this GCD feature, and I'm not sure that it is. Oh, and it's not the least common multiple. So I think GCD, greatest common denominator. No, I take that back. That's probably not it. Let me think about this before I do something stupid, but I think this calculator has the ability to find the greatest common factor. I just don't remember how. And if it really does have that ability, then I will show you that feature on the calculator once I figure it out. But as I'm looking at the calculator right now, I'm not sure I know how to do it, and I think I'd probably write something down and do something that would be just confusing, and that's never a good idea. I'd probably do a good enough job of confusing you when I know what I'm talking about. It would hardly be the time to introduce something that I'm not sure about. So I'll come back to that, and if it can find a greatest common factor that's the number, I will do it. So I mentioned that the greatest common factor can be just a number. Also could be just a letter or a combination of a number and a letter. I'll show you next how a greatest common factor can be a letter. And the greatest common factor, if each term has the same letter, then the greatest common factor has a letter, and the power that you get is the largest the smallest exponent of all the terms. So I'll write this better because I think you couldn't get what I said by my just talking. So the greatest common factor only consists of a letter, or I'll say it only might be deceiving. So it consists of a letter when each term has that letter. And then if each term has a specific letter, the GCF will contain that letter that they all have in common with the smallest of the exponents. For example, in this binomial, 8x to the fourth minus 9x to the fifth, there's no number greatest common factor because the biggest number that divides evenly into both 8 and 9 is 1, but they both have an x, so an x needs to be part of my greatest common factor. To get the right exponent, you look at each of the x's and you pick the smallest exponent. So for that binomial, the greatest common factor would be x to the fourth. This is a trinomial, and it doesn't have a number common factor because the only number that divides evenly into 10, 3, and 8 is 1, because the only number divides evenly into 3 is 1 and 3, and 3 doesn't go into 8 nor 10. The greatest common factor here is only going to consist of a letter because each of the terms has the same letter, and the greatest common factor always has that letter with the smallest exponent, and so it would be y squared. If I gave you something like this, 10xy squared plus 7x squared y cubed minus 8x cubed y to the fourth. Again, it doesn't have a number GCF because there isn't. The biggest number that divides evenly into 10, 7, and 8 is 1. But all three pieces of this trinomial, they both have the letter x and they both have the letter y. So the greatest common factor has to have both an x because all three terms have an x, and a y because all three terms have a y. When I look at the x's, the first x doesn't have an exponent written, so there's an exponent of 1 that's implied. The second x has an exponent of 2. The third x has an exponent of 1. When I'm picking a letter greatest common factor, I take the smallest of the exponents. So in the greatest common factor, you'd have an x to the first power. For the y's, all three pieces have a y. The exponents on the y's are 2, 3, and 4. The smallest of those numbers is 2. So the greatest common factor for that problem would be xy squared, or x to the first y squared. Usually you don't write an exponent when it's 1. And I'll do one more example, and then I'll get into actually how to do the section. If I gave you something like 9x squared plus 2x plus 1, It doesn't have a number common factor because the only numbers that divide evenly into 9, 2, and 1 is just 1. So I wouldn't say it has a number common factor. And it doesn't have a letter common factor because the last term doesn't have an x. So I would say in this one there's no GCF. I guess if we had to say if we had to pick a GCF for this problem, if we were forced to do it, we'd say 1 is the GCF. So that's the concept of greatest common factor, and it's the important thing to understand how to look at a polynomial and figure out the number part and the letter part of a greatest common factor, and then we'll have to do more. Once we identify the greatest common factor, the section wants me to do something with it. Specifically, the section wants me to factor out the greatest common factor. So in each of the problems between 1 and 16, I'm going to do this. First, I'm just going to identify the GCF. And then I'm going to write it, the GCF, to the left of a parentheses. So let me get started with those two steps, and then I'll talk about how to finish it up. Usually, most students, when they're factoring out a GCF, fill in the inside of the parentheses just in their head without really thinking about what they're doing. I'll talk about what we actually have to do if we can't just do it in my head. So I look at problem 2, but the numbers 6 and 12, 6 is a number that divides into 6, 12 is a number that divides into 6. So 6 is going to be part of the GCF. It's the biggest number that divides into 6 and 12. The first term, 6x, has the letter x, but the second term doesn't have an x. So in this case, the greatest common factor is just going to be the number 6. It's not going to have an x or a letter because both terms don't have a letter. So I'm going to start off, I'm going to write an equal sign because what I'm going to write is equal to the original problem. I'm going to write the greatest common factor 6 to the left of a parentheses, and then what I'm going to put inside the parentheses has to have the same number of terms as the original problem. The original problem has 2 terms. Inside the parentheses I need to have 2 terms. As long as what I factor out doesn't have a negative sign, in addition to having 2 terms, the inside of the parentheses has to have the same sign that my original problem has, so which is going to be a minus. So I'm starting off filling the inside of the parentheses. I carry the sign down, and I need to have 2 terms, one to the left of the minus sign and one after the minus sign. And how do you fill out, if you don't know already? To figure out what to put inside, we divide. Divide by the GCF. So to figure out what to put in place of the 6x, I divide 6x by the GCF of 6. To figure out what to put in place of the 12, I divide the 12 by 6. And again, generally we don't do this, we do this in our head, but we can definitely do this until we get good at it. So for the first piece, when you divide 6x by 6, the 6's cancel, you're left with an x. The fraction is gone because I don't have anything in the denominator, canceled out the entire denominator. The 12 over 6, that just reduces to 2, and it's not a fraction. This is the whole answer to problem 2. I've done the instructions. This is considered factoring. Factoring is rewriting a polynomial, or rewriting any expression, as a multiplication of 2 factors. The nice thing about factoring, you can check. And to check, you can multiply your answer and it should equal the original problem. More often than not, I don't check when I factor out the greatest common factor because it's kind of easy for me and it goes quick. But right down here I could do my checking. So here's the checking part for problem 2. My answer I said is 6 times x minus 2. And to multiply this out, I'd go 6 times x and 6 times minus 2. 6 times x is 6x. 6 times minus 2 is minus 12. When I clear the parentheses that I wrote in, because it equals the original problem, I know my answer is right. I'm going to do the same thing for problem 4. So I'm going to look at problem 4 and decide, is there a number other than 1 that divides evenly into 25, 20, and 5? And I'm good at doing numbers in my head, so it's obvious to me that 5 is the number part of the GCF, because 5 divides into 25, 5 divides into 20, 5 divides evenly into 5, and there isn't a bigger number that divides evenly into those 3 numbers. So I'm going to start off writing the number 5 to the left of my parentheses, but before I write my parentheses, each of the terms in this problem has the letter y, and when each term has the same letter, then the letter needs to be part of the greatest common factor, and the exponent you need is the smallest of the exponents, and the third y, because it didn't have an exponent, there was an exponent of 1 that was implied, and so I'm going to attach a y to my 5, and then I'm going to write a single parentheses. To figure out what goes inside the parentheses, because I didn't factor out a negative, the signs that were in the original problem are going to go inside the parentheses, so the signs were minus and plus. And now to figure out what goes inside, usually I could do this in my head, but if I wanted to be formal, I'd take the 25y cubed, divide it by the 5y that I factored out, and at this point I don't even worry about signs because I have my signs already in there. So then I'll take the 20y squared, divide it by the 5y that I factor out. I'll take the 5y, divide it by the 5y that I factor out. This division, I go 25 divided by 5 is 5. And on the y's, I subtract the exponents. There's 3 y's in the numerator. There's an implied 1 for the exponent in the denominator. And then I'm going to get y to the second power for the letter for the first term. Second division, 20 divided by 5 is 4, so 4 is going to be the number part, and for the y's I subtract the exponents. The 2 that's written in the numerator and the 1 that's implied in the denominator, when you subtract those, you get y to the first power. You could write an exponent of 1 there, but it's preferable if you don't write it, because 4y is more efficient than writing 4y to the first, and they mean the same thing. And then the last division, anything divided by itself is 1, and I need to include that. This is my answer. And I'll check this, but eventually I'm going to stop checking because my videos get too long anyways. And the checking is easy, and it's like I said, I usually don't do it. So for the checking, I need to take my answer and multiply it out. To multiply out my answer, I'd go 5y times 5y squared. Then I'd go 5y times minus 4y, and I'd go 5y times 1. For the first multiplication, I'd multiply the 5's, and I'll add the exponents on the y's, so I just kind of wrote it so you could see what I'm going to do. Multiplying the 5's, I'd get 25. The y that didn't have an exponent has an implied 1, and this gives me a y cubed. The second multiplication, I multiply 5 times negative 4, and I add the exponents of the y's. Each of the y's has an exponent of 1 that's not written, but it's implied. 5 times negative 4 is negative 20. When I add the exponents on the y's, I get y squared. In the last multiplication, anything times 1 is itself, so 5y times 1 is 5y. when I look at this line and I compare it to the original problem, it's exactly the same as the original problem, and that means my answer is right. So anytime I factor out a greatest common factor, it's one parentheses factoring. I usually write a monomial to the left of a parentheses, and I should always take my answer and multiply it back to get the original problem. When I look at problem 6, the coefficients of the first terms are 1 and the last term is 9. Because the first two terms don't even have a coefficient that's shown, there won't be a number part of my greatest common factor. There will be a letter part, and the exponents on the x's, the first x has an exponent of 3, the second x has an exponent of 2, the third x has an exponent of 1. The greatest common factor is going to be just a single x. Now if I want to figure out what to put inside the parentheses, because I didn't factor out a negative, I know the signs are going to be the same as the original problem, so this minus sign and this plus sign will find its way into the parentheses. And then to figure out what goes inside, if I can't do it in my head, I take the x cubed that was in the original problem, divide it by the x that I factored out, and here I subtract exponents. X cubed over x to the first would give me an x squared to go in the parentheses. Won't worry about the sign. For the second piece inside my parentheses, I'll take the x squared that was inside the part of the original problem, divide it by the x that I factored out. I'll subtract the exponents and get x to the first power. And I won't write the exponent of 1, but it still means x to the first power. And to figure out the last thing inside the parentheses, I'll take the 9x from the original problem, divide it by the x that I factor out. The x's are going to cancel, the fractions are going to be gone, I'm going to be left with a 9. Let me check this just to make sure I have it right. So to check, I need to go x times, so this is supposed to be my answer. To check, I'll go x times x squared, and then x times minus x, and x times 9. For x times x squared, I add the exponents on the x's. This is 1x and 2 for the exponents, so you get an x cubed. Here, the second multiplication, I get a positive times a negative, so I get a negative. I add the exponents on the x's and get an x squared. The last multiplication are two positives, so I get a plus sign, and I'll just leave the 9 and the x written next to each other. So I've checked it, and I know my answer is right because when I multiplied it back, it equals the original problem. Problem 8, again, because both terms don't have a number, then you're not going to have a number as part of the greatest common factor. The greatest common factor is only going to consist of a letter, and when the letter is your common factor, you need the smaller of the exponents, and the smaller of the exponents is the 2. So I'm going to write an equal sign, and I'm going to write a y squared, and then I'm going to figure out what goes inside the parentheses. I know this minus sign is going to stay inside the parentheses. And now I'm going to go 3y cubed over y squared, and y squared over y squared to figure out what goes inside the parentheses. First piece, I subtract the exponents on the y's. I'll get y to the first power. This 3 is going to remain, so I'm going to get a 3y inside the parentheses. The second piece, y squared over y squared, is just 1. So that's the answer. If I wanted to, I could multiply this back out, and it should equal exactly the original problem. Again, but my videos get too long anyway, so I'm going to try to speed them up a little bit with stuff that I think you can do. 10 and 12, 14 and 16 look messy. They're going to have, kind of 3-part common factors. First, in 10, I look at the numbers 15 and 10, and those are both, 5 divides evenly into both of them, and it's the biggest number that divides evenly into both of them. So I'm going to write a 5 first, and then both terms have an x. I take the smaller exponent of the x, which is an x cubed, and both terms have a y. I take the smaller exponent of the y and get a y squared. So what I did for the last few problems, dividing, is completely fine to get the insides of the parentheses. It's not really what generally is done. You kind of divide, but not really. So I'll show you how most students wind up doing problem like number 10. But if you want to do what I did for the first 4 problems and divide to figure out what goes inside the parentheses, you're fine. But I'll kind of do it in my head more like I do it. So for the first piece, 15 divided by 5 is 3. I had 4 x's. I took 3 of them out. I have 1 x left, and I'm going to write it as an x to the first power. The second piece, it had 2 y's. I took both y's out, so I don't get any y in my first piece. So 15 divided by 5 is 3. I had 4 x's. I took 3 x's out, leaves me with 1 x. I had 2 y's. I took 2 y's away. I'm not left with a y. Second piece, started with a 10. I took a 5 out. 10 divided by 5 is 2. Started with 3 x's. Took all 3 x's out, so I don't have any x's after the minus sign. Started with 4 y's. Took 2 y's out. I'm left with 2 y's. So that's generally how I factor out a greatest common factor rather than showing the dividing. And so that's what I'm going to consistently do. But you can resort to that dividing if you like that better. So when I look at 32 or 12, I see the numbers 32 and 24. What numbers go into 32? 1 times 32 is 32. So 32 is 1 times 32. It's 2 times 16. It's 4 times 8. I think those are all the factors of 32. So those are all the numbers I can think of that divide into 32. And for 24, 24 is 1 times 24. It's 2 times 12. It's 3 times 8. And it's 4 times 6. This is actually going to be an important skill, to be able to look at integers and know all their factors. And the biggest number that's a factor of both is 4. 4 divides evenly into 32. Whoops, I take that back, is 8. 4 is a common factor, but not the greatest common factor. 8 divides evenly into 32. 8 divides evenly into 24, because 8 is a factor of 32. 8 is a factor of 24. 8 is going to be the greatest common factor. If I would have written 4 and not an 8, I'd get an answer that's factored, just not completely factored. And on the test, if you don't get the biggest common factor, you'll lose a point, but you'll get some partial credit. So the numerical greatest part of the greatest common factor is 8, because 8 is the biggest number that divides into 24 and 32. Both terms have an a. The smaller exponent is the second a, the a to the first. Both terms have a b. The smallest exponent on the b is the b to the sixth. So the greatest common factor for 12 is 8a b to the sixth. The minus sign that's in the original problem is going to go inside the parentheses. Now I'm going to go 32 divided by 8 is 4. The first piece had 2 a's. I took one of them away, so I'm still left with 1a. The first piece had 6 b's. I took all 6 of them away. I don't need a b there. Second piece, 24 divided by 8. Started with a 24. I divide by what I factored out. 24 divided by 8 is 3. It had 1a. I took the a away, so I don't need any a's after the minus sign. The second term had 7 b's. I took 6 of them away, so I have 1 b left. So inside the parentheses should be a 4a minus 3b. And again, I can check if I want to, but it takes me more time to check than it does to do the problem. And I'm pretty comfortable factoring greatest common factors, and I don't always check these. To get the number part of the greatest common factor here, if I just can't look at it and know, I could write the factors of 15. 15 would be 1 times 15 and 3 times 5. And I can write the factors of 9, which are 1 and 9, and 3 and 3. And the factors of 6 are 1 and 6, and 2 and 3. Each of the numbers has 3 as a factor. And my number part of my greatest common factor is going to be a 3. Now I look to the letters. The first one has an X, the second one has an X, but the third one doesn't have an X, so there isn't an X as part of my greatest common factor. First has a Y, second has a Y, third has a Y. There has to be a Y as my greatest common factor, and I take the smallest exponent. The first Y has an exponent of 1, the second Y an exponent of 3, the third Y an exponent of 1. So Y to the first power would be part of my greatest common factor. First has a Z, second has a Z, third has a Z. The smallest exponent they have in common is a Z to the first power. That's the greatest common factor. Now I make my parentheses, bring this plus sign down, that minus sign down, and start taking away. The first one, I take the 15 and divide it by 3 and get a 5. I didn't factor out an X, so I'm going to leave that X cubed. It had one Z, but I took the one Z away, so I don't need to write a Z anymore. It had one Y, I took one Y away, I don't need to write a Y. Had one Z, I took the factor of the Z out, I don't need to write a Z. So first I get a 5X cubed. Second piece, I go 9 divided by 3 is 3. I didn't take out any X's, so I need to leave the 2 X's there. It started with 3 Z's, I took 3 Y's, I took one away, so I'm left with 2 Y's, which I'll write as a Y squared. It started with 2 Z's, I took 1 Z away, I'm left with 1 Z. So that says 3 X squared, Y squared, Z, for what that's worth. Last piece, I'll take the 6 and divide it by 3 and get a 2. It had one Y, I took the one Y away, I don't need a Y. It had one Z, I factored out the one Z, I don't need a Z. So the answer to this, in case it's not that readable, is 3YZ times 5X cubed plus 3X squared Y squared Z to the first minus 2. Perfection. All right, 16, last one in this grouping. I look at the numbers 8, 6, and 10, and I'm quick enough to know that 2 is the greatest common factor. If I don't, I can write the factors of 8. 1 times 8 is 8, and 2 times 4 is 8. Write the factors of 6. 1 times 6 is 6, 2 times 3 is 6. Write the factors of 10. 1 times 10 is 10, 2 times 5 is 10. Each one of the numbers, 6, 8, and 10, 2 is a factor of it, and there isn't any other common factor, so 2 is the greatest common factor. So when I go to write my one parentheses, the first number I'm going to write is the number 2, and then I'll hunt out the letters. There's an R first, R second, R third. I need the smallest exponent, that's that R to the first. There's an S in the first, an S in the second, an S in the third. The smallest exponent is the first S, or the last S, which has an exponent of 1. There's a T first, a T second, and a T third, and the smallest T exponent is a T to the first. So now I'm going to fill up the inside of my parentheses, bring down the plus sign, bring down the minus sign. First piece, I go 8 divided by 2 and get a 4. The first piece has 3 R's. I took 1 R out, so I have 2 R's left over. The first piece had 1 S, I took the S out, I don't have any S's left over. The first piece had 2 T's, I took 1 T out, I'm left with 1 T. Middle piece, 6 divided by 2 is 3. It had 3 R's, I took 1 R out, I'm left with 2 R's. It had 2 S's, I took 1 S out, I'm left with 1 S. It had 1 T, I took 1 T out, I'm not left with a T. Last piece, 10 divided by 2 is 5. It had 1 R, but I took the R out, I don't need an R. It had 1 S, I took 1 S out, I don't need an S. It had 1 T, I took 1 T out, I don't need a T. I believe that's the answer. this is the answer to the last problem. All right, so that's the first kind of problem. Greatest common factor factoring will come up a ton this semester. It's kind of the easiest kind of factoring to get good at. So hopefully, even by just me doing 8 problems, you're starting to feel good. The next group of problems ask me to factor out a -1. And this is a common question to ask when the first term in a polynomial is negative. And if you factor out a -1, then inside the parentheses you write the opposite of the original problem. So I'll say factor out a -1, which means to write a -1 out in front of a parentheses, then write the opposite of the original problem inside the parentheses. So I'll follow my instructions. I'm going to factor a -1 out. So I'm going to write a -1 outside of parentheses. Then inside of parentheses, I'll put the opposite. The opposite of -3x is +3x. The opposite of +5 is -5. I'm done. This is the answer. If I wanted to, I didn't really have to show the 1. It would be okay if I wrote -3x minus 5. That's still considered factoring out a -1, even though I'm not showing the 1. A negative sign written in front of a parentheses without a 1 still means -1. And just like in the last group of problems, I can check. If I wanted to check this, I can take my answer, which is -1 times 3x minus 5, and clear the parentheses. I'll go -1 times 3x and -1 times -5. -1 times -3x times 3x is -3x. -1 times -5 is +5. And anytime I'm factoring, this is kind of a GCF factoring, but not really. But anytime I'm factoring out anything, I should be able to multiply back what I think is my answer, and it should always equal the original problem. So I'll go through these kind of quickly because they're easy and I won't check so much. So for problem 20, I'm going to factor out a -1. So I'm going to write a -1 in front of a parentheses, and then inside the parentheses, I'm going to put the opposite. The opposite of -x is +x. The opposite of -4 is +4. So you get -1 times the quantity x plus 4, and that's your whole answer. Probably should be writing equal signs because what I've written is equal to the line above it, but you'll notice I didn't for problem 18. It's not the biggest deal whether you do or don't. It's probably more mathematically proper to show equal signs when you're writing something that's equal to the line above it, but a lot of times I get lazy and forget to. So I should be able to do 22, 24, and 26 quick because there's not much to them. So I'm going to write a -1 to the left of a parentheses, inside the parentheses the opposite. The opposite of -7w is +7w. The opposite of +16 is -16. Again, it would be okay and possibly better if I wrote -7w minus 16. That would still be satisfy the instructions of factoring out a -1. 24, I'll go -1 times, then the opposite of -2x is +2x. The opposite of -3y is +3y. The opposite of +9 is -9. And then the last one in this grouping, 26. I'll put a -1. The opposite of -13y is +13y. The opposite of +4z is -4z. The opposite of -11r is +11r. And again, I could have written this. It's okay and probably better at least for some teachers, it's infinitely better. For me, I'm not that picky. I don't really care. Almost messed this up. So the opposite, no, I didn't mess it up. I almost messed up, but I saved myself from doing something stupider than I should. Okay, next group of problems is a combination of factoring out a -1 and a GCF. We won't show the -1, we'll just show the GCF. So when I look at the instructions for problems 27 through 38, it says factor out the opposite of the GCF, and that implies factor out a negative with the GCF. So this means factor out a negative of the GCF, because the opposite of something is kind of the negative of it. And so in problem 28, I'm going to write an equal sign, then I'm going to write a negative sign, because factoring out an opposite means to factor out a negative. But a negative is not just enough, because this problem has a common factor. The common factor is between 20 and 15. 5 is the biggest number that divides into each. So in addition to my negative sign, I'm going to put a 5, and they both have a y, and the smaller of the exponents is a y to the first. So what's going to go in front of my parentheses? Always for 27 through 38, I'm going to put a negative because I'm asked to factor out an opposite, and then the GCF. And the GCF is still the biggest number that divides evenly into the numbers, and and if they have a letter in common, the smallest exponent. So now I'm going to divide by 5 and take one y away and flip the signs, because the opposite makes me flip the signs. So this negative sign is going to flip to positive. That negative sign is going to flip to positive, because when you factor out a negative, you flip the signs, or you put the opposites in. But here, because I'm factoring out more than just a 1, it's not enough just to change the signs. Like when I did 26, I just changed the signs because I only had a -1. It's not enough for this problem. For this problem, not only do I need to change the signs, but I have to divide the numbers by 5 and take a y away. It was kind of silly to write that plus, because usually if the first term inside of parentheses is positive, you just don't write a sign. The numbers that need to go in my parentheses, 20 divided by 5 is 4. Well, what goes first in my parentheses, 20 divided by 5 is 4. I had 2 y's, I took 1 y away, I'm left with 1 y. Second, 15 divided by 5 is 3. Technically, -15 divided by -5 is +3. That's why it's a positive there. It had 1 y, and I took 1 y away. This is going to be my answer. Let me check to show that that works. So to check this, it'd be better if I would have written this. That plus sign looks silly there. So to check this, I'll go -5y times 4y and -5y times 3. The first multiplication, you go -5 times 4 times y, which is -20y squared. The second multiplication, you go -5 times 3 times y, and you get -15y. And since that's the original problem, I feel good about this. So I don't think I did a horrible job telling you what to put in front of the parentheses. I'm not that sure I did that good telling you what to put inside the parentheses, so I'll try to do better for the next few chances that I have at it. So again, it asked me to factor out an opposite, so the first thing I'm going to write down in my work is a negative sign. Then I look at the numbers 42, 24, and 4. 4 doesn't go into 42. 4 goes into 40, 4 goes into 44. 4 is not a common factor. But 2 goes into 42, 2 goes into 24, 2 goes into 4. So 2 is going to be the number common factor. They all have an a, and the smallest exponent of a is a to the first power. Usually when I'm greatest common factor factoring and I factor out a negative, the first thing I do is put in my signs, and then I will get each of the pieces, the rest of what goes inside the parentheses. When I factor out a negative, I flip signs. This negative is going to turn to a plus. I'm not going to write a plus sign, it's going to be implied. This plus is going to turn to a minus, because when you factor out a negative, you flip signs. That minus is going to turn to a plus. So I have my signs dealt with. I won't worry about the signs anymore. And now I'm going to figure out what goes inside the parentheses in addition to the signs. First piece, 42 divided by 2 is 21. The first piece had 5 A's. I took 1 A away. I have 4 A's left. Second piece, 24 divided by 2 is 12. I had 3 A's. I took 1 A away. I'm left with 2 A's. Last piece, 4 divided by 2 is 2. I had 1 A, I took it away, I don't need an A. Again, if I want to, I can check. This is the answer. It's the best answer I could come up with at this point. And if I wanted to check, I'd go negative 2A times 21A to the 4th, and negative 2A times negative 12, that's an A, believe it or not, 12A squared, and negative 2A times 2. The first one I'd multiply negative 2 times 21 and get negative 42. I have 1A and 4 A's. Those multiply together to be 5 A's by adding their exponents. Next one, negative 2 times negative 12 is positive 24. 1A and 2 A's will give you 3 A's. The last multiplication, you multiply negative 2 times 2 and get negative 4, and you leave the A. Because this and this are exactly the same, then I know my answer is correct. So when I'm factoring out a negative, I kind of go in steps. I fill my signs up in my parentheses, and then I fill each of the individual terms. So it's a little more complicated than just factoring out a negative 1. The factoring out the negative causes the signs to flip, and then the greatest common factor makes me divide numbers and subtract exponents. (32) is written in an odd way because this is a first power term and this is a second power term, but I'm still going to deal with, I'm just going to leave it like this. So I'm going to factor out an opposite, which means to factor out a negative, and then 5 goes into 5, 5 goes into 10. 5 is the biggest number that goes into both 5 and 10. They both have y's, and the smaller exponent of the y's that they have in common is y to the first. Inside my parentheses, this negative sign is going to change to a positive sign. You generally wouldn't write that positive sign. That positive sign is going to flip to a negative sign. So I'm going to not write that positive sign because it's not necessary, but it's what happens. Now I'm going to deal with the number part. So for the first piece, I factored out a 5y. So I'd go 5 divided by 5 is 1. And I had a y. I took the y out. I don't need to write a y. So the first thing I'm going to write in my parentheses is just a number 1. Second piece, I go 10 divided by 5 is 2. There were 2 y's to start. I took 1 y out. I'm left with 1 y. That's going to be the answer. And again, if I want to, because I'm not maybe doing the best job on these, I can check these. I can go negative 5y times 1 and negative 5y times negative 2y. The first one, anything times 1 is itself, so negative 5y times 1 is negative 5y. The second one, you multiply the negative 5 and the negative 2, and you multiply the y and the y. Negative 5 times negative 2 is positive 10, and y times y is y squared. 34. Factor out the negative because the instructions ask me to factor out the opposite. 2 is the biggest number that goes into 2 and 4. Both pieces have an a. The smaller exponent is the a to the first. Both pieces have a b. The smaller exponent is the b to the second. I make my parentheses with my signs. The negative sign flips to plus. That negative sign flips to plus. Probably shouldn't write that negative sign. That plus sign, should I say. So I'm going to write negative 2ab squared and just a plus sign. Now I'm just going to do regular dividing and subtracting out the exponents. So the first piece started with a 2. I factored out a 2. 2 divided by 2 is 1, so I won't write a number. The first piece had 2 a's. I factored out 1a, so I'm left with 1a. The first piece had 2 b's. I took 2 b's out. I don't need a b. Moving on to the second piece. The second piece had a 4. I factored out a 2, so I go 4 divided by 2 is 2. The second piece had 1a. I factored out 1a, so I don't need to write an a. The second piece had 3 b's. I took out 2 b's. I'm left with 1 b. So once I factor out a negative, I immediately go inside my parentheses and get the signs doctored up, and then I don't worry about the signs when I'm figuring out the terms that need to go on either side of the signs. So this would be the best answer for 34. So negative 2ab squared times a plus 2b would be a perfect answer. (36) and 38 look pretty monstrous, but I'm sure I can deal with them. So for all the problems through 38, I'm factoring out first a negative and probably more than a negative. But when I factor out a negative, I flip the signs. This negative sign is going to turn to a plus sign. That plus sign is going to turn to a minus sign. And that minus sign is going to turn to a plus sign. And again, usually I wouldn't write this sign. So in my answer, my signs are going to look like that. Now I'm going to get more outside my parentheses than just a minus sign. I look at the numbers 15, 12, and 9, and 3 is the biggest number that divides into each of those. There's an x squared, and an x. There's an x in each piece. The smallest exponent is that x to the first. Each of the 3 pieces has a y. The smallest exponent is the y to the first. Each of the pieces has a z. The smallest exponent is z to the first. So now I'm just going to divide each of the numbers by 3, take away 1x, 1y, and 1z, have my signs dealt with so I won't worry about the signs anymore. So for the first piece, it had a 15. I factored out a 3. 15 divided by 3 is 5. It had 2 x's. I took 1x out. I'm left with 1x. Had 1y. I took the y out. I don't need a y. Had 1z. I took the z out. I don't need a z. So the first thing I'm going to have is a 12, or 5x, should I say. Next piece, I go 12 divided by 3 is 4. Technically, it's 12 divided by negative 3 is negative 4, if you want to be literal. But I have my signs dealt with, so I don't worry about them. I treat the rest of this just like a regular greatest common factor problem. This second piece has 2 x's. I took 1 x out, so I'm left with 1x. It has 3 y's. I took 1 y out, so I'm left with 2 y's. It has 3 z's. I took 1 z out, so I'm left with 2 z's. Last piece, technically you go negative 9 divided by negative 3 and get positive 3. I already have my plus sign there. Or I can just go 9 divided by 3 is 3. It had 1x. I took the x out. I don't need an x. It had 1y. I took 1y out. I don't need a y. It had 1z. I took a z out. I don't need a z. So my answer to 36 is going to be that. Kind of not written that perfectly with a huge gap, but I'll live with that huge gap. 38, I'm going to write my minus sign, and then inside the parentheses, this minus sign turns to a plus, that minus sign turns to a plus, that minus sign turns to a plus. Again, usually you don't write a first sign as a plus. So I'm going to have my template for my answer to look something like that. Just that plus sign doesn't need to be there. Now I look at the numbers 8, 6, and 10. 2 is the biggest number that divides into 8, 6, and 10. Each of the 3 pieces has an r. The smallest exponent is the r to the first. Each of the 3 pieces has an s. The smallest exponent on the s's are the s to the first. Each of the 3 pieces has a t. The smallest exponent on the t is the t to the first. Now I'm going to divide each of the numbers by 2 and take 1 r, 1 s, and 1 t away. From the first piece, when I divide 8 by 2, I'm left with a 4. Technically, it's negative 8 over negative 2 is positive 4. First piece had 3 r's. I took 1 r out, so I'm left with 2 r's. First piece had 1 s. I took the s out, so I don't have an s. First piece had 2 t's. I took 1 t out. I'm left with 1 t. Moving on to the second piece. Technically, it's negative 6 over negative 2 is positive 3. Already have my sign in. I usually just would go 6 over 2, and it's 3. Second piece has 3 r's. I took 1 r out. It has 2 r's left. Second piece had 2 s's. I took 1 s out. I have 1 s left. Second piece had 1 t. I took 1 t out. I don't need a t. Last piece, negative 10 divided by negative 2 is positive 5. I already have my signs in, so I really would just go 10 divided by 2. The second piece has 1 r, 1 s, and 1 t. I took out 1 r, 1 s, and 1 t, so I don't need any letters at the end in my last term. So that would be the best answer for that problem. Again, I can check these by multiplying back out, and when I multiply out, I should get exactly the original problem. I think I'm butting up against the last group of problems. The last group of problems are a little bit harder to check, and they're a little bit tricky when you first see them. So here, when on either side of a sign you see the same parentheses, if there's each piece, each product, as x times x minus 5 is one product and 2 times x minus 5 is another product, if each piece has the same product or the same factor, then that's going to be part of the GCF. So the GCF in each of the problems between 39 and 52 is going to be the parentheses that they have in common. So at the beginning when I said the GCF is usually something, this is when the GCF can be a binomial. So for problem 40, I'm going to write an x minus 5, and then from the original problem, if I factor out an x minus 5, I'm just going to take an x minus 5 away. And from the first piece, if I take an x minus 5 away, I'm left with an x. I didn't factor out a negative, so that plus sign's not going to flip. It's going to stay plus. And from the second piece, I took the x minus 5 away, and I'm left with a 2. To check this, it's a little bit tricky. To check this, I have to multiply out the original problem and multiply out my answer. So it's hard to check. I only check the first one. To check, you need lots of work. I need to multiply my original and my answer, which is really unusual for checking. So my original was x times x minus 5 plus 2 times x minus 5. The first one, the original, if I multiply it out, I go x times x and x times minus 5. X times x is x squared. X times minus 5 is minus 5x. And then I go 2 times x and 2 times minus 5. 2 times x is positive 2x. 2 times minus 5 is minus 10. I'm going to combine those terms, and I get x squared minus 3x minus 10. That's multiplying out my original. Now I'm going to multiply out my answer. So my answer was x minus 5 times x plus 2. I'll do foiling. Firsts are x times x, which is x squared. Outers are x times 2, which is a positive 2x. Inners, minus 5 times x, which is minus 5x. Lasts, minus 5 times 2 is minus 10. The outers and the inners here combine to be a minus 3x. You get x squared minus 3x minus 10. Because when I multiply out my answer and I multiply out my original problem, because they multiply out to be the same trinomial, then the two problems are equal to each other. So the checking is really, really cumbersome and not something I generally do, because they're really easy to factor once you do a few of them. So I'm not going to check these, I'm just going to do them. And each of the problems between 39 and 52, and I don't know where problem 42 is, so sorry that it's not there. I don't know what happened to it. But hopefully, even skipping 42, I have enough. So on either, both pieces here, the first product 6y times z plus 7, the second product 5 times z plus 7, there's a z plus 7 in common, so that's going to be my common or greatest common factor. When I factor out the z plus 7, I take it away from each piece. And when I take the z plus 7 away from the first piece, I'm left with a 6y. From the second piece, when I take the z plus 7 away, I still have the minus 5. So I'd say this factors into z plus 7 times 6y minus 5. So these go quick, too. They're all set up the same way. For 46, both on either side of the minus sign, there's a 5x plus 1. So my greatest common factor is going to be a 5x plus 1. When I take the 5x plus 1 away from the first term, I have an x left over. When I take the 5x plus 1 away from the second term, you can see what's left over. It's a minus 4. So 46 would factor into 5x plus 1 times x minus 4. To check it, I'd have to FOIL this, simplify that. I'd have to multiply this out, simplify that, and both the original problem and this one, you FOIL and simplify. When you multiply both of them out and simplify, they'll equal the same thing. 48, there's a 6x minus 1 in common. When I factor out the 6x minus 1s, I can see what's left if I cross out the 6x minus 1. First, there's going to be a 5x. Second, there's going to be a plus 6. So this factors into 6x minus 1 times 5x plus 6. This kind of factoring only works if the contents of the two parentheses are exactly the same. If the parentheses aren't exactly the same, then it just doesn't work, this strategy. Last few problems, same strategy. Problem 50, there's in common a 2x minus 3y. So I'm going to write a 2x minus 3y in a parentheses. After it, I'm going to make a parentheses. And then to figure out what goes inside the parentheses, I just scratch out that 2x minus 3y so I can see what goes inside. What goes inside is 7x squared minus 4. I'm done with 50. I'll do the same thing for 52. On either side, there's a y plus 4. When I factor out that y plus 4, I'm left with 7y and a minus 2. This is going to be an important skill when we get into the next section, I believe. So that's, I think, everything in this section. Hopefully it feels good to you, because factoring common factors, even when they are this kind of complicated, is an important skill to have. It'll come through the whole chapter. This whole chapter, we learn a bunch of different factoring techniques, and generally the first step in every problem is to see if there's a greatest common factor, and if there's a greatest common factor, factor it out, and then apply the new technique that we learn in the sections that are later in this chapter. So this greatest common factoring won't leave us. It'll come back and stay here the whole chapter through. So you need to get really comfortable with greatest common factor factoring in order to make the transition into the next sections. All right, that's got to be enough. And it wasn't even an hour and a half. Hopefully it's like an hour and 10 minutes, so it wasn't a horribly torturous video.